Welcome to our little primer on references and pointers, an incredibly important subject for you to really get the hang of in C++, often used as interview questions just because it's so hard and it weeds out the wheat from the chaff. So we are going to teach you to be the wheat. So how are we going to do this? We're going to go through the references and pointers, compare them, how are they different, how are they similar. Then we're going to look at how you'd perform common operations using both of these constructs, and figure out what these funny symbols, the ampersand and the star symbols, actually mean, because they can mean different things in different contexts, to add insult to injury. And we're going to challenge you to repoint and rewrite. You'll figure out how and what that means in just a second. And we're going to figure out when to use references over pointers and vice versa, just as the end, as a little bonus. So let's start off by comparing those pointers to references. What are they? Well, they are both a way of referencing an address in memory, a way of saying, I've got an object, it's in memory, but this is just a pointer to that object. So pointers, quite obviously, are that. References are a little bit more subtle. The main difference between pointers and references is whether you can change the address they are pointing at. So with a pointer, yes, you can. You can point, or you can repoint your pointer to a different location in memory so that it's pointing at a different object. On the other hand, a reference is always fixed to pointing at a certain address in memory, and the only thing you can do is change the contents of that address in memory. So, consequently, a pointer can be null, so you can have a pointer pointing at nothing. Obviously, if we try and use the contents of nothing, it's going to be a bit problematic. We get dereferencing errors and things like that. However, with references, you can't have null. It has to be initialized to something because we can't change it later. So if it's pointing at nothing, it will remain pointing at nothing forever. So basically, C++ prevents us from having that problem, and we have to initialize it with something in the first place. We've got accessing contents. So a pointer is not hiding the fact that it's actually a memory address. So in order to access the contents, we have to put a star in front of the pointer, which goes ahead and grabs the contents from that memory address. A reference is being more subtle about it. It's saying, I'm going to pretend like I'm the actual object I'm pointing at. So to get the contents is very easy. You don't have to use any special syntax. Accessing the address. Again, the pointer is not hiding the fact it's an address, so you just use the pointer. It is the address. References, on the other hand, they are hiding the fact that they are an address, so we have to use an ampersand in front of it. And we're going to go over the meaning of ampersand and star in just a second, remember. Then we've got changing the address. Here, a pointer can be changed. You can just assign a new address to it. A reference, it's obviously not allowed. And then changing the value. Here, with a pointer, to change the value, we have to use the star again, very similar to what we've seen in accessing content, just it's on the left-hand side of an equals. Again, with the reference, to change the value, no special syntax required. We just change the value. So, as promised, what is this star and asterisk all about? Or rather, the ampersand and asterisk. Well, when we are using a variable rather than declaring a variable, they have one set of meanings. So, for example, the star in this context goes in front of the variable, and we can read it as being the contents of actor pointer. Now, technically, this is called dereferencing because you are going to the area where the memory is, where the object is, and you are getting that object back. Like looking in an index, you are dereferencing. Then you've got the ampersand here. The ampersand also goes before either a variable or a reference, and it gets you the address of a variable or reference. So you can think of this as the address of operator. Now they have completely different meanings when used as part of the type when declaring a variable. So when we're declaring a pointer, when we're declaring a reference, you need to watch out because these stars and ampersands mean something else. The star, for example, in this context goes after the type which it applies to, and it basically means that it's a pointer to that object. So uActor star means a pointer to uActor. It's often helpful to read these types backward. So it would be star uActor. It would be reference uActor. And similarly, the ampersand goes after this type, but this time it means a reference to uActor. So all the differences about pointer and versus reference, this is where they come into play when you're defining the type of a new variable. And to add insult to injury, they can all have different meanings in different contexts, for example, and can be a bitwise and, but we won't go into any detail with that. In these contexts, this is what they mean. Okay, we're going to have a challenge for you in just a second, but I want to show you the setup of my console app here. I've just created a new console-only app in Visual Studio just to illustrate the point of what's going on over here. At this point, just follow along as I'm writing the code, and you can copy this code into your own editor later on. And I'm going to set us up with a few variables outside of the main so that they can be accessed globally. It's generally not good practice, but it's going to be good for us to illustrate the point here. So the first thing I'm going to do is create an integer, which is going to be our object in memory. I'm going to call it val to mean value and give it a value of 1. I'm going to create a second integer, second location in memory called val2, and I'm going to set this one to 2, so it's got a different value. Next up, I'm going to create a pointer to an integer in memory. So a pointer to an integer in memory is int star. It could be int space star. It could be however you like. The white space isn't matter. The point is that there's star after the type means that it's a pointer to that type. And I'm going to call it val pointer just to keep it clear for us. And then if I want to assign it an address, I need to get the address of value. And we know address of is the ampersand, so address of val, like so. And then I'm going to do the reference as well. So I'm going to do int ampersand to be a reference, and then val ref equals. Now here it's hiding the fact that it's a pointer. So what we're going to do is just get the value like so. No need to do an address of like we did for val pointer. Okay, and then what we're going to do, we're going to create a function for printing out the contents of these. We're going to do just a void function, call it print vals, and inside that function I'm going to do a stud cout, so I'm going to need to include iostream as a header, so include chevrons iostream at the top of the file, and then in print I'm going to do a stud cout, and I'm going to have the value first, so val, followed by val2, then followed by val pointer. Now I want to get the contents in this first line. In fact, I'm going to print out that I want the contents, so stud cout values. This is going to be what our first line is, and then I'll end it off with a stud endl. Val pointer, and I'm going to get the contents of that, so that will be the star operator for val pointer. And then finally we want the val ref. And to get the contents of val ref, we don't have to do anything special because it's hiding the fact that it is a reference. And then I can end off with a stud end line, end L, like so. So I'm just going to add in some spaces for formatting for the val2 and before the val pointer. Save that, and I'm going to go ahead and run it without debugging. So start without debugging, or Control F5 in Visual Studio. And let's see if that works out. I will actually need to be calling that from main, because otherwise it's not going to do anything. So I'm going to call from main my print vals, like so. And we're going to go ahead and run it again. Okay, so we've got val1, val2, val pointer, val ref, that's the values. And one more thing, I want to print out the addresses. So I'm going to copy this line down and call it addresses. And I'm going to have the address of val. So for that I need my ampersand. Address of val2, again, ampersand. The address of val pointer, as we know, it isn't hiding the fact it's an address, so we don't need the star. And the address of val ref, we do need the ampersand again. So you can start to see the difference between pointers, references, and values in terms of getting the address and getting the value in this print val function. Now I'm going to do Control F5 to build and run again. And here we go. We can see the addresses of val, val2, valPointer, and valRef. And you can see that actually valPointer and valRef have the same address, and it's the same address as val, which makes sense because they are pointers to that address in memory. So it's time for your challenge to repoint and rewrite. I want you to take the code that I've started, use that as a starting point, and we're going to try and repoint the pointer. Point that pointer to val2 instead of val1. How does that address change when you print out? Reprint stuff after having repointed, and then rewrite the value at the pointer and rewrite the value at the reference, each time printing out and seeing how those values, what other values change. Pause the video and have a go at this challenge. Okay, welcome back. We're going to dive right in. It's fairly straightforward once you know how. So how are we going to, first off, what's the first point? Repoint the pointer. So we've got a val pointer, which we are going to try and repoint. So for that, we need to assign it a new address because it's not, and it's an address itself. We can just assign the address, no need for a star, no need for anything. And I'm going to get the address of val2. So the different variable, it was currently pointing at val. I'm going to point it at val2. And then I'm going to print vals again. And let's do a control F5, see what that does. So the first time round, we've got this set of addresses. The second time round, you can see that the val pointer's address has actually changed, and it's now pointing at the same address as val2. Exactly what we thought it would do, given that it has repointed. And I didn't look at it, but if you have a look again, control F5, you will notice that the value in valPointer has also changed to reflect the value in val2, which obviously makes sense because it's pointing at that memory address. Okay, now what happens if we change the contents of valPointer? To do that, we need to do star valPointer, and I'm going to set it to 3 so that it's distinguished from everything else. I'm going to print the values, and I'm also going to change the contents of the valRef. So valRef equals 4, and then I'm going to print the values after that. And let's take a look at what that produces as output. I'm going to build and run it. So after we have changed the value of valPointer, you can see that both the value of val2 and valPointer have changed to 3 because they are the same memory address. They are the same object in actual fact. Obviously, the addresses haven't changed because we haven't been repointing any of our pointers. And how about when I change the reference? You'll notice that the reference, because it hasn't changed, it can't change, will always point to the same memory address as val. It has changed to 4. And so has val, because they are, again, the same object. So changing the reference will change the values. Changing the contents of the pointer will change the memory address it's being pointed at. Simple as that. They are just pointers to bits of memory. Now, as promised, a little bit of a bonus. When would you be using a pointer or a reference? So the golden rule is to use references unless you can't, because basically they are newer and generally speaking, they are safer. Now, I'm saying newer. They've been around pretty much as long as C++, but before C++, there was a language called C, and only pointers existed back then. So part of it is for keeping backwards compatibility with C that references exist, but part of it is because pointers are more powerful. So sometimes you will need to use pointers. Sometimes the APIs that we're using in Unreal will require pointers, and that's fine. In that case, we do need to use pointers, but always remember that they are slightly more dangerous because of the very fact that we can change what they are pointing at. They can sometimes lead to confusion. They can sometimes cause us issues. So with that word of warning, go forth and use your pointers and references. If you have any questions to do with pointers and reference, go ahead and ask them in the Q&A and go through and check that you really understand the output of the example that we've just done in this challenge, as it will really help you understand how pointers and references are different.